The Beauty of Recursion, or Why Broccoli is a Work of Art. Hi, my name is Julia Cordero, and today I'll be introducing an elegant concept in computer science. Let's say Grandma gives you broccoli. Are you wrinkling your nose yet? Or are you marveling at its computational implications? Don't yell, just hear me out. We can describe the way broccoli grows with a concept called recursion, explained with this code written in Python. If we make a function that raises 2 to any power we want, then we tell the computer that when our power, or n, is 0, then the answer is 1. If n is anything else, then the answer is the output of the function when the input is 1 less than n, then all multiplied by 2. Wait, I just defined a function, then told the function to use itself? How does that work? It just returned to itself. Might we even say return to a course of itself? Recourse? Recursion? Get it? A recursive function in computer science is when a function uses itself. Wait, why doesn't it keep using itself infinitely or send an error? Because we defined a base case. That's when n equals 0. That tells the computer what to do when it reaches the smallest instance we want it to or is possible to calculate. If n was 2, for example, the computer would skip to the else, plug in 1 into the function since that's 1 less than 2, then have to skip to the else again, plug in 0 since it's 1 less than 1 to the same function, and finally get 1. Then it multiplies 2 times 1, as was according to the definition of the function, and then 2 times 2, because it first had to figure out what 2 to the 0 and 2 to the first were before it could tell me what 2 to the second was. Imagine having to write that whole thing out. That's 6 lines of extra code. When we code recursively to make models, robots, and cooler apps, it not only saves our computer scientists from carpal tunnel syndrome, but makes algorithms more efficient and elegant. And not just for powers of 2, it can be for lots of functions. Now, how does broccoli come into this? Well, see this original stock? That's our initial case, when n equals 1. Let it branch out, that's n equals 2, building on what it knows from the base case. Keep taking it apart and you'll get to your edible nth case. Just like in computer science, where we have one base case that every other case must trace itself back to, here's an original stock that every little piece is a copy of and must trace itself back to. Broccoli looking more interesting now? How about this cool Fibonacci spiral? Also, that shell your cousin brought back from the Bahamas last summer? Icicles on your front porch? They all exhibit recursive concepts. What else in your life is hiding these beautiful patterns that build on each other? Thanks, and that's all. And for all you aspiring computer scientists out there, stay loopy.